My name is Richard Lawler. I'm the Engineering Director for Abu Dhabi Aviation, and I'm responsible for keeping our aircraft serviceable. Abu Dhabi Aviation has been in business for 40 years, so it's quite a long time. Their main aircraft that they've got here is the AW139, the Bell 212 and 412, and the Bombardier Dash 8 aircraft. The type of operations that we perform here are offshore, EMS, which is medical service, and utility or ad hoc flights for just general purpose. We also have an AW139 VIP configured aircraft. Having our aircraft grounded for unserviceabilities, not having the parts available, can quickly run into being very expensive. We have the Honeywell HUMS system fitted to our AW139, and we utilise that for track and balance to keep the aircraft in a smooth state. And we also use it for monitoring the aircraft's health, more from a vibration point of view. So we'll do regular data downloads and we'll look at that data to see if there's any exceedances or trends that are trending towards an exceedance. So we can perform corrective action before it reaches an unserviceable state. So that means we can order parts in, advise the OEM of a solution. So the HUMS system is really an extremely important system that we use on a regular basis, and it's also becoming mandated with offshore contracts. And the regulators are now also imposing that we have HUMS systems fitted to our aircraft. The HUMS system allows us to monitor a vibration signature, and we are able to keep that signature within a safe level, so we've got a safe product in the air.
My name is Kurt Conkey. I'm the Vice President of Maintenance for Columbia Helicopters. Columbia Helicopters is a commercial operator. We operate the Columbia 234 Chinook and the 1072 tandem rotor helicopters. We operate all over the world, oil exploration, firefighting, construction, and logging. And critical in a heavy lift helicopter or any helicopter is to be able to maintain those vibration levels that are acceptable and within limits. So again, that's why we selected the VXP, because it could provide that solution that quickly to the levels that we needed to keep the wear and tear down on our two platforms. It got our vibration levels down lower than we've ever seen with other equipment. Since using the VXP, we've seen a 60% reduction in unscheduled engine drive shaft removals. If you want to keep a machine, safe and keep your wear and tear and your downtime to a minimum, it's the solution to go with.
Engine vibration testing can be performed using the Honeywell VXP system. The Honeywell VXP system can be used to gather data and perform tests on various types of engines. For engine vibration testing, VXP is the approved replacement for all obsolete or no longer supported testing equipment. In this video, we'll show you how to perform an engine vibration test using the Honeywell VXP system. The VXP system works by gathering data from vibration sensors mounted in 3 locations on the engine. This data is sent to an acquisition unit which contains software designed to analyze and interpret the vibration data. The data is then displayed on a laptop for review and analysis by a technician. To perform the test, you'll need a Honeywell VXP system with engine-specific accessories. You'll also need the engine maintenance manual. The maintenance manual contains a data sheet that you'll need to refer to during the test. We'll also discuss how to review the test data and what to do in the event of a failed test. The VXP system can be used to gather data from various engines. In this video, we'll be working with a Honeywell T53 engine. For other engines, you'll need the appropriate software and accessories. When you purchase the VXP system and engine-specific accessories, you'll be mailed a kit that contains the acquisition unit, or AU, a Panasonic Toughbook laptop that comes pre-installed with the software you'll need, the vibration sensors, and cables and brackets you'll need to connect the sensors to the acquisition unit. The VXP analyzes engine vibrations by collecting vibration data from 3 vibration pickups, or sensors, installed on the engine. The location of the sensors is very important. Refer to the maintenance manual and T53 application help for the proper installation locations. Once the sensors are installed, connect and route the cables from the sensors to the AU. When routing the cables, be careful not to bend the cables or route them through a location that could get excessively hot. Connect the cables to the ports on the AU. Turn on the Panasonic Toughbook. The VXP program will launch automatically. Select Connect to AU. Verify the software in the AU. You should be running the T53 version of the software. This can be verified in the upper left of the screen. If the correct software is not installed, refer to the help file for instructions on installing the software appropriate to your engine. Set your aircraft ID. We recommend using the aircraft tail number or engine serial number. This will create a folder with the name you specified on the computer. Any downloaded test data will be saved in this folder. After setting the ID, download and clear all logs on the AU. Before performing any tests, go to Setup and Utilities. Under Version Information, verify that the application part number is the latest version. If you have any questions about this, contact your distributor or Honeywell Aerospace Technical Support. From the Select Procedure screen, select T53 Engine Vibration Test. Refer to the datasheet from the Engine Maintenance Manual and operate the engine at the specified N1 and N2 speeds. Once the engine is stabilized for at least 30 seconds at the specified speed, click on Start to gather the vibration data from the sensors. Data from the 3 sensors will be displayed simultaneously. As long as the readings don't go into the red, the test is successful. Once the data is recorded, click on Stop. You'll now have the opportunity to save the data to the laptop. When saving the file, we recommend adding the power setting to the file name. Repeat the test for each power setting specified in the Engine Maintenance Manual datasheet. The higher power settings will require the aircraft to be in hover or forward flight. As long as the recorded data is less than the established limits, the engine has passed the vibration test. For each power setting, record the data displayed on the VXP DU. This data can also be saved and accessed later using the VXP display system. If any vibration reading exceeds the engine operating limits, this operational point must be repeated while using the diagnostic section. If any part of the vibration test fails, we can further investigate the test data to see if we can determine the cause of the problem. For example, further investigation may help us determine if it's an issue caused by the engine or airframe. To do this, we'll collect the raw spectral data from the test. This enables us to hone in on specific peaks in the vibration data collected from the sensors. From the Select Procedure screen, go to Vibration Signatures. Engine N1 SIGs, operate the engine at the specified power settings and collect the data. At this point, the data is collected in the AU, but we need to save it to our computer. Click on Download in the left panel. It will be defaulted for the files and folder, so just click Save. Verify the location and click OK. Once the files are saved to your hard drive, you'll be given the opportunity to clear the logs on the AU. If you'd like to leave them on the AU, select Cancel. Once we're done collecting all the raw spectral data, we can then email the saved files to Honeywell Engineering for a resolution. Once the vibration test is complete, wait till the engine is cool before removing the test equipment and sensors. Click on Disconnect before physically disconnecting any sensors. The downloaded test files are stored in the C drive under the Chadwick folder in the Aircraft ID folder. Any spectral logs are also saved to the same location. The Honeywell VXP display program is a fast and efficient way of performing engine vibration tests, saving you time and money. For questions or concerns with the VXP program, contact your VXP distributor.
Honeywell is considered synonymous with safety. Our number one goal is to drive safety regardless of mission, whether it's EMS, oil and gas, search and rescue, government VIP, corporate VIP, it doesn't matter. Our job is to drive safety. And so many of the solutions that we have in our portfolio are anchored around that. We also offer differentiation in the industry through our SATCOM products, whether it be SkyConnect to satisfy HEM's mandate, or whether it's the Aspire 200 HDR to give that connectivity where previously it was unavailable.
Connectivity is important for today's helicopter operator for several different reasons based on their mission type and profile. Emergency medical services, helicopters are able to utilize the high-speed data network to send and receive real-time data back and forth from the hospital to the helicopter or the helicopter back to the hospital, providing real-time vitals and statistics for the medical personnel in that golden hour when it's necessary. For our oil and gas customers, we're able to provide real-time tracking capabilities for asset management and being able to track where the helicopter as well as the crew is at all times, providing and ensuring safe transit, as well as able to provide HUMS capability and send back real-time aircraft status and health monitoring for that helicopter as it transits from point A to point B. From a VIP perspective, our operators are able to utilize the connectivity in a helicopter to provide them an office in the sky, which enables them to basically be able to do VPN, networking capabilities, internet, email, make voice over IP calls, and literally be as connected with the high-speed data capabilities on board the aircraft just as they were in the office. Military and government customers utilize high-speed data in many different ways. From the cockpit side, they're able to utilize it for ComNav and surveillance capabilities, CNS-ATM, which allows them to fly in airspace along with the airliners and able to transit to and from their sites as a normal air transport aircraft. From the back end of the aircraft, the military government customers are able to utilize high-speed data based on their mission requirement. Sometimes that is high-speed data, sometimes that's just voice only, sometimes that's providing real-time situational awareness for the guys back at the home base, and sometimes that's transmitting information to and from the ground for the ground troops.
I think the trend in the industry is moving or migrating to a fully integrated connected aircraft. That means the aircraft is talking to the ground is talking to the satellite is talking to the aircraft. It's all being intertwined. It's a matter of time before everything is connected, and I believe Honeywell is moving in the direction to be a first mover on that.
At Honeywell, we're committed to keeping your combat helicopters mission ready. Our HUM systems increase safety and reduce costs for military helicopter operators through the early detection of mechanical faults, providing better maintenance planning and resulting in less unplanned downtime for your fleet. Honeywell's HUM solutions help commercial helicopter operators to enhance safety, reduce maintenance costs, and increase aircraft availability. Portable systems balance and track rotors, monitor vibration, and provide component diagnostics. Onboard systems provide full HUMS capability, including integration with SATCOM for real-time exceedance alerts.